So hopefully you took a second and worked out these sig fig problems. If you didn't, you have still a chance. Pause this video. Go ahead and look at these 6 problems. See if you can figure out how many significant figures each of these have. And then press play again. Benefit of online teaching. All right, so let's look at the first one. So 0.04450. So these are non-zero numbers, so that means they count. Okay? These are leading zeros, and so remember we said that the leading zeros, that was rule 3, and leading zeros do not count. This is a trailing zero. So then we have to see, do we have a decimal? We do, so it's after the decimal, so then that means that this guy counts. So nope, nope, yes, 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 yes. So that's 4 yeses, so 4 sig figs. All right, let's look at the next one. The 5.0003, the 5 and 3 count because they're non-zero, rule 1. These guys are interior because I have a non-zero here, a non-zero here, so these are interior, so they count. So I have 1, 2, 3, 4, 5 sig figs. All right, so the next one, 10 decimeters is equal to 1 meter. So I want to talk about the 10 first. So let's talk about how many significant figures this has. So your first thought might be, okay, well the 1 counts, the 0, that's a trailing 0, there's no decimal, so ambiguous. But what else is here? This equal sign. This equal sign should be a huge, like, boom, 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 red flag or whatever, letting you know that this guy is an equation, and so if it's a number, the 10 or the 1 in an equation, it's an exact number. So the 10 and the 1 have the exact same answer. Those have the same number of sig figs, meaning exact. Or you could also say they have unlimited sig figs, that's kind of saying the same thing. All right, let's do the next one. 1.000 times 10 to the 5th. So remember, if it's scientific notation, we don't care about the 10 to the 5th, we ignore that. And then we come over here. The 1 counts because it's a non-zero. These guys are trailing zeros, but it's after the decimal, so they count. So we have 1, 2, 3, 4 sig figs. So that's how many we have there. All right, next one. 0.00002. All the 2 counts because it's non-zero. All these zeros are leading because there's no other non-zero number here. Leading doesn't count, so this 2 is the only one that counts. So it has 1 sig fig. All right, last one, 10,000. So the 1 counts because it's a non-zero number, and then we have all these zeros. They're trailing zeros. Do we have a decimal place? Nope. So we don't really know if these zeros are there to tell me how big the number is or if they're there to count. Okay, so this answer could be 1, or it could be that all 5 of them count. I don't really know. And so when I don't really know because of the rules, not because I don't know because I just haven't studied sig figs yet, then my answer would be ambiguous. And so you just write ambiguous. Oh. So ambiguous. Okay? Now, the whole point of that section was to be able to look at a number and say how many sig figs. But most of the time, if we're doing chemistry, we're either looking at a piece of equipment, like we did in the graduated cylinder that we did a couple of sessions ago, and then taking the measurement there, or we're going to take a bunch of numbers and then do some math with it and have a final answer. So we use this technique of looking at the number and figure out the sig fig so that when we do a calculation, we can figure out how many sig figs our final answer should be in. So you have to know this to be able to do the next part. Okay, so on the next video, we're going to talk about how do we figure out sig figs when we're actually doing calculations.